Hello everyone, you're welcome to Mathematics Tour. This is the Cambridge Igcse Mathematics Paper 4, written in October-November 2024. There are 10 questions in this paper. Let's jump into the first question. Before then, if you are seeing this channel for the first time, please kindly subscribe to my channel to support my hard work. Also, like, comment, and share this video. Let's jump into the first question. Question 1a from figure 1. Write 70 as a product of prime factors. So, you can write 70 as 7 times 10. Then, you can have it as 10 as 2 times 5. So, we can say that 70 as a product of prime factors will be 2 by 5 by 7. So we can write 2 by 5 by 7. So Roman figure 2. Find the highest common factor of 70 and 112. Okay. So we already know that 70 is equals to 2 times 5 times 7. So let's write 112 as a product of prime factors. Okay, so what we need to do is this. Let's break 112 into 2. So since this is an even number, so 2 can go, so that will be 2 goes in 11, that is 5 in 12 6, so that is 2 times 56. So we can break it down like this. 50. Okay, let's write 112. Okay, will be 2 multiplied by 56. So we have 2. So we need to break this. It's still an even number. 2 can still go. It will be 2 and 28. We have another one. We can still go. We'll break 28. That will be 2 against 14. Okay. So we can still go. Okay, there's no space. So I'll write it like this. 14 will be 2 against 7. So that means 112 will be equals to 2 to the power of 1, 2, 3, 4. 2 to the power of 4 times 7. Okay, now so to get the highest common factor of 70 and 12, okay, so we look at the smallest number, okay, common to the two numbers. So that will be the highest common number. So in 70, so we have 2 to the power of 1 here, 2 to the power of 4 here. So we'll pick the smaller one, that is 2, because the two numbers must be available in the two numbers. So here we have 5 to the power of 1. So we have 5 to the power of 0, which is 1. So that can be neglected. So 7 to the power of 1 here, 7 to the power of 1. So we have 7 to the power of 1. So which is equals to 14. Okay, so we can write it as, so it will be 2. To be 2 by 7, okay, which is 14. So we can just write 14 here. Okay, so Roman figure 3, find the lowest common multiple, that's LCM of this and this. Okay, so 70x to the power of 4, y to the power of 2. Okay, so 70 as a product of prime numbers. Okay, so we have it up there. Okay, so this will be 2 by 5 by 7, then x to the power of 4, then y to the power of 2. Okay, so for the second one, 112, okay, 112, x to the power of 3, y to the power of 5. So 112 as a product of prime numbers, okay, or factors, will be 2 to the power of 4 multiplied by 7. Then we have x to the power of 3, then y to the power of 5. So since we want to get the lowest common multiple, so here, okay, we compare each of the terms here, okay, and we pick the higher one. Okay, so for HCF you compare them, okay, and pick the smaller one. Okay, so but for lowest common multiple you compare the two numbers and you pick the higher one, okay, or the larger one. Okay, So here we have 2 to the power of 4, 2 to the power of 1. Okay, so the larger one is 2 to the power of 4. So the LCM will be equals to, we'll pick 2 to the power of 4. Okay, then 7, we don't have, we have 5 to the power of 0 here, and we have 5 to the power of 1 here. So because we can actually put 5 to the power of 0 here because it is 1. Okay, so you just take it as if you have 5 to the power of 0 here, and you have 5 to the power of 1. So to pick the larger one, so we'll pick 5 to the power of 1, then multiplied by, so we have 7 here, we have 7 here, so and they are equal, so we just pick 1, then multiplied by x to the power of 3, x to the power of 4. So we select the larger one, which should be x to the power of 4. Then finally, y to the power of 2 and y to the power of 5, we'll pick the larger one, which is y to the power of 5. Okay, so if you are dealing with LCM and the term is not there, so you can write it like this, just like what I did for 5 to the power of 0, which is 1. Okay, so that is it. Or alternatively, if a term is missing, so you can just pick the one that is available there. Okay, so if you don't want to write this, then you can just pick 5 straight away. Okay, so now 2 to the power of 4 times 5 to the power of 1 times 7. So these 3, so these 3, okay, we multiply to 560, then x to the power of 4, then y to the power of 5. So that will be our final answer. So it will be 560 x to the power of 4 and y to the power of 5. So part B, simplify a, this is division law of indices. It will be a to the power of 12 minus 4. That will be a to the power of 8 straight away. So a to the power of 8. Okay, so this, to simplify this, you can just, okay, b, we cancel b here. Okay, 5 here 1, 5 in 20, that is 4. So you have 1 times c left, that is c, over 2 times 4, you have 8. So this will be c out of 8. Okay, part E, solve this. So subtract 12 from both sides. We are left with 2x to be equals to 11. Okay, so x will be equals to, so this will be equals to 11. So x will be equals to 11 out of 2. So that will be equals to 5 whole 1 out of 2. So 5 whole 1 out of 2, or 5.5. So they are equivalent. Okay, so let's go to the next question. That will be at D. So here you can write this as 4 over 1 x over 1. So we need to linearize, okay, to make it a straight line. So we don't have we don't want to have this denominator there. So to do so, you have to multiply through by the LCM of the denominators. So the LCM of 5, 1, and 1 is 5. Okay, so I'll just say 5 into 34 plus 2x over 5. Okay, so equals to 5 into 4 minus 5 into x. Okay, so that this will cancel this. Okay, so this will give us 34 plus 2x. Okay, then equals to 5 times 4 will be 20, then minus 5x. So if you bring negative 5x to the left hand side here, it becomes 5x, then plus 2x, okay, equals to 20. Then 34 goes to the left hand side and becomes negative 34. So this will be 7x equals to 20 minus 34, that is minus 14. Okay, so x equals to minus 14 out of 7, that will be equals to negative 2. So x is equals to negative 2. So the next question here, find p when d is equals to 7 and m equals to negative 8. So p straight away will be equals to 7 plus cube root of negative 8 all squared. Okay, so p will be equals to 7 plus cube root of 64. Okay, so this will be p equals to 7 plus square root of 64 will be 4. So p is equals to 11. So I have 11 here. So Roman figure 2. Rearrange the following to make M the subject of the, rearrange the formula to make M the subject. Okay, so to do that, okay, let me write this again. Okay, I think it's okay from here. Excuse me. So we have to firstly bring this one here. D needs to go to the left hand side. That will be P minus D equals to cube root of M squared. Okay, so it's like the M squared is hidden now. So we have to cube both sides. Okay, when you take the cube of both sides like this. Okay, so cube, we cancel cube root. So we have P minus D cube to be equals to M squared. Then finally, take square root of both sides to make M the subject of the formula. So square will cancel square root. So we are left with M equals to square root of P minus D to the power of 3. P minus D to the power of 3. So we can write our final answer here. So M equals to square root of P minus D to the power of 3. Okay, so let's go to the next question. That will be question 2. On the grid, draw the image of triangle A after a reflection in the line x equals to 1. Reflection, so in the line x equals to 1. So x equals to 1 will be the vertical line here. Okay, so we can just draw. Okay, let's scroll up a little bit. Okay, so if you draw this line here, so this is the mirror line. Okay, so this is the mirror line. So we need to reflect, okay, this shape here, triangle A rather, okay, along x equals to 1. Okay, so if we do that, this point will remain here. So my best practice is to label the diagram or the shape or the object. This will be P, this will be Q, and this will be R. Okay, so point P and R remain on the line. Okay, so on the line of symmetry. Okay, so only point Q goes to the other side, and from here, if you count 1, 2, 3, 4. So 1, 2, 3, 4. Okay, so this is what you have here. So then let's connect them together. So we're going to have something like this. This connects to this, and this connects to this. So this will be the image of the object. So we can just write maybe A prime. Okay, so this will be Q prime here if you want to do that. Okay, so that is the reflection. So we still have 1 against minus 1 as the point here. Then this one remains 1 against minus 3, and this is this. Okay, so that is pretty correct. So let's see the next question. One figure 2. The image of triangle A after an enlargement by the scale factor of 1 over 2 with center 5, 1. Okay, so we need to take note of two things. So the scale factor is a fraction, 1 over 2, and the center of enlargement is 5, 1. Okay, so these two are important for us to enlarge the object A. So it's going to become smaller because of the scale factor, which happens to be a fraction. Okay, so the center of enlargement is x equals to 5 and y is equals to 1. So this is the center of enlargement. So this point here. So if you like, you can just put a cross here. So that is the center of enlargement. Okay, so from the center of enlargement, let's count to each of the points of shape A. Okay, so from the center of enlargement, let's start from center of enlargement, let's count to point P. Okay, let's see the steps. Okay, we have 1, 2. Okay, then 1, 2, 3, 4. So you have to follow that order. Okay, so let me just draw here. So you may not necessarily write anything. So you can just draw something like this. So like this, downward, and like this. Okay, so it's okay. So this will be 2 down, then 4 to this side. So you have to multiply this by the scale factor times 1 over 2. So this will be 1 down, then times 1 over 2. This will be 2 to the left. So from here now, from the center of the arrangement, so the object, the image will be at 1 down, then 2 to the left. So 1, 2. So that means P prime will be here. Okay. So I've used Q prime here. So let me just put P prime prime. Okay, so that I will not end up having Q prime here and there. Okay, so P prime prime. Okay, so for point R, so you count 1, 2, 3, 4, 1, 2, 3, 4. So that is 4 down, 4 to the left. So if you multiply by the scale factor, you are going to have 2 down, 2 to the left. So you have 1, 2, 1, 2. So it's going to be here. So that would be R prime prime. And for the last one here, so we just have 1, 2, 3, 4. So we don't have x. So that is 4 down multiplied by 2. So that would be 2 down. So this will be, let's count 2 down here, 1 and 2. Okay, so it should be here. That will be Q prime prime. So let's connect the points together. So the first one will be P prime prime and Q and R prime prime, like this from here. You connect this. So, sorry, no, made a mistake. I picked the wrong one. It's here. So you pick it from here to here. Then that's P prime prime. Then this again, this and this, and the last one will be this and this. Okay. So you may want to label this maybe A prime prime if you want. Okay, it's not required. So that is the enlargement of shape A. So it will be smaller due to the scale factor, which happens to be a fraction. Okay. So and if you compare the sides, this is 1, this will be twice. Okay. So this is 1, 2, 3, 4. This should be 2. Okay. So let's go to the next question. Describe fully the single transformation that maps triangle A onto triangle B, A onto B. So describe fully the single transformation that maps triangle A onto triangle B. So let's look at this, A onto B. So we need to observe this. This is P, Q, R. So let's label this. If you look at point P here, so it's similar to this point here. So this will be the image. So I can call it P. This will be point P prime prime prime. And if you look at this spot here, it's now here. So I can call this one R prime prime prime. And this point will be Q prime prime prime. So let's put Q prime 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 here. So if you observe, if you compare these two, you see that it's a kind of rotation, okay, towards this direction like this. Okay, if you rotate it like this, okay, so it's going to look like this. So that means we have rotation. So for rotation, we need to get the center of rotation, the angle of rotation, and the direction. So those three things will be required, okay, for us to have 3 marks there. And another hint I used to give my students is that when you say 3 here, so you are expected, at least this should guide you, that you need to put 3 things here, okay? So just being working smartly, okay? So now the first thing is to find the center of rotation. So to get to the center of rotation, so I have to join corresponding points together, then I will bisect them. Okay, so for instance now, P and P prime prime prime. So this one, oh sorry, let's reverse that. Okay, so let's join P and P prime prime together. So I have to bisect this. So when I bisect this, okay, then I'll take another one again. Okay, so I'll take another pair, okay, which could be maybe R and R prime prime prime. So we bisect them again. So to see where the two perpendicular bisectors, meet is the center of rotation. So let's bisect this first line first. So we need a protractor and we need a compass and a pencil, a pair of compasses and a pencil. So for me, I have the pair of a pair of compasses here. Okay, so let's bisect this line. So center at P, okay, then take a radius that is a little bit more than half of the line. So let's draw an arc. Okay, you can target the center where it will pass through. So I think we are good like this. So do something here. Then we also do the same thing somewhere around there too. Arc up and down. Okay, we are good there. So with the same radius, okay, so center here. Okay, I think I didn't place the center on P very well. Okay, but this will guide us to, okay, I need to bend this a little bit. Okay, center here. I still need to bend it a little bit so I can rotate it. Okay, so center at P prime prime like this. Fully place it. I think I'm good like this. Then let's intersect this. Okay, so we should intersect this as well. Okay, so this is the first perpendicular bisector. So then maybe I can use another color. Okay, I think I'll just use a broken line. So from here, let's draw and connect them together. So, okay, so I can extend it. Let's select this one, and we'll extend this one to this one here. Okay, I think we are good to go. So the next is to select another pair. So let's select R prime 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 and R here. So we need to draw another line from here to this R prime here. Okay, good. So we can now bisect that line as well. So let's bisect this. We need this. Okay, so center at R prime prime prime. Okay, so let's rotate this. We need to target the center. So okay, let's open this one a little bit. So we need to target the center where it passes through. Okay, I think it's not good like this. Okay, so I can draw one here. Let's draw this line here. Okay, then I will draw the other one along this side too. So I have to target where it is likely to pass. Okay, so I'll do this one. So you need to take note of the arcs. Okay, so I'm using this one here now. Okay, let me just put a dot there. So and this one. Okay, then with the same radius. Okay, so I'll put it at point R, center at R. Then so let's arc this. So we'll intersect this one here. Okay, so this is the point here now. Okay, so we intersect this one too. Okay, so this is the arc here. So I have to join these two, this one and this one. So let's connect them together. So this spot here. So from here, let's draw, and it passes through this spot here. Okay, so let's adjust this one very well. So this one is here. Okay, so let's adjust this one. So let's take this one away. So this is the line. This one, it passes through this place. Okay, hope I'm not missing. No, I think I picked the wrong one. No, I picked the wrong one. It should be this. I think, yes, okay. So this is the one. Okay, so it will be this one here. Okay, exactly. So I got you now. So it should be this here. Passes through these points. Okay, so they are very close. So if you look at it very well, so if you look at it here, somewhere around here, okay, somewhere around here. Okay, so due to compasses, I think when I was doing the first one, I didn't place it very well. So close to, so it's on x equals to 2 and then y equals to 4. So it should be this spot. Okay, so if you use your compass very well, you should have that. Okay, so I know the center now. So this is the center of rotation. That is x equals to 2, y is equals to 4. This is center of rotation. So, and we can see the direction and as well as the angle. So let's draw a line, a normal line. Okay, so to get the angle and the direction, so let's draw a line from P prime prime to the center of enlargement. So P prime 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 to the center of enlargement, this center of rotation rather, sorry. Okay, then we also draw a line from that center of rotation to the corresponding object. Okay, that is P. Okay, so like this. Okay, so if you look at it very well, this will be a right angle here. So you don't need to put your protractor to measure this. So this is a right angle. So if you look at it from here now, so from here, how would you rotate this one? You see that this one will go like this. Okay, so clockwise direction, it will go like this as I told you. Okay, clockwise direction. Okay, so from here, you rotate it, you lift this one up, so this point P will come to this spot here. So that is clockwise direction, 90 degrees clockwise direction. So I'm done. So the name of the transformation is rotation. Okay, and the center is I think I wrote 2,4. Okay, I'll check that later. 2,4, then 90 degrees clockwise. 90 degrees clockwise. Okay, so one mark for this, one mark for this, and one mark for this. Okay, so let me check the center. Okay, 2,4, that's correct. So the point A, comma B is reflected in the line y equals to k. Okay, so where k is an integer and b is less than k, so write the coordinate of the image of points A, comma B in terms of A, B, and k. Okay, so let's do something like this first. It is the line of symmetry is line y equals to k, so that means it is um, a horizontal line. That's the implication. Okay, maybe y equals to 2, y equals to 3, y equals to 4. K can be any integer. Okay, so that means our reflection mirror line is a horizontal line. So I'll just draw something like this for you to understand the explanation very well. Okay, so this is the mirror line. So this is k. So that is y equals to k. So coming. So let's do this. So this will be k. That is y equals to k, the mirror line. Okay, so if we have a point here, so let's say this is the point here, okay, and the point is a comma b. It has the x and the y value. Okay, it has the x value and it has the y value. A is the x value and y is the b is the y value. Okay, so what happens when you try to reflect this point, okay, through this mirror line? Okay, definitely it will come here. Okay, and the distance here, okay, will be equals to d. So the distance here, I think this is too far. So the distance here too will also be d, okay, because they must be equidistant. Okay, so that is one thing you should take note. And if this is along x-axis, a straight line, okay, so the point will be here. It will still be along the x-axis. So the coordinate of the x-axis remains the same. So for the image now, okay, so a remains a, okay, it remains a. Okay, so I can just put this sign here so that it will become this is the image. Okay, so but for the y, so that is where we need to be very observant. So at this spot here, when you rotate this point here, so the coordinate of y will increase, it will change. Probably, let's say for instance now it's at 2, okay, so when it goes up, so it will definitely change. Okay, so at the point we know the value of b, okay, so the image of b will just be, it will be equals to k plus d, that is the k here. So just add the distance here to this k, so it will be the location of this point b, the image of b. So but we don't know the value of k. Okay, sorry, we don't know the value of d, so we cannot use this. So we need to deploy another means. Okay, now what you should take note is this: if from here, if this is k for instance now, okay, so double of k, if you reflect point b through this line, so we're going to have the y-axis will become 2k. Of course, this 2k will be too much. Okay, so then you need to subtract the value of b from it. Okay, so then it will be equal to this. So 2k minus b now will be equals to k plus d. Okay, so I'm going to show you an maybe a practical example for you to understand better. Okay, so we are told that so this will be the coordinate of the image, but I will explain by giving you a practical example now. Okay, now another thing I want to explain before that is this: this is k, so this is b, so the distance d will be equals to k minus b. Okay, so that's the distance d, to be k minus b. Okay, so now let me show you a practical example for you to understand this better. So let's say we have the x and y coordinate, for instance. Okay, so let's say this is the y coordinate and this is the x coordinate. So I just want you to understand this particular point very well. Okay, so if I put, okay, let's take this. So this is the y coordinate and this is the x coordinate. Okay, so if we have the mirror line, let's say somewhere around here, for instance, and let's say this is at y equals to 5, for instance. So the mirror line is y equals to 5. So I'm using I'm giving you a practical example now. Okay, so if we have a point, let's say the point is here. Okay, so the point, the x coordinate, let's say it is 1, and the y coordinate of this point, let's say 2. So that means this point is at x equals to 1, y equals to 2. So now, if you reflect this now, let's say we have 3 steps, for instance, now like 1, 2, and 3. You have 3 points, okay, between this point and the mirror line. So we have to transfer the same 3 points up here. So from here you have 1, 2, and 3. Okay, so you can see that if you trace this now, the coordinate here of x remains 1 because it's still along the x-axis here, which is still 1. Okay, so that is why I said here that the a remains a here because you are still along the x-axis. Okay, fine. So the distance here is 3 steps and the distance here is also 3 steps. So that is clear. Okay, now let's look at something now. So I told you that if you know the value of d here now, so you just add it to the k, so that will give you k plus d. So in this case now, k is equals to 5 and d is equals to 3. So k plus d now will be equals to what? 5 plus 3, that will be 8. So this will be 8. Okay, that's why I said this will be very correct. But let's say we don't want to put 8 directly. Okay, now for the distance from the x-axis, okay, the distance for the x-axis, okay, that is from here to here, okay, between this and this now. Okay, so if you double it, okay, so let's say it is 2k now because k is from like 0 to 5. Okay, that is k. It's like from 0 to 5. So if we double it, that will be 2 times 5, 10. So that means we're going to have something like this here. Okay, a line here. So we're going to have 10. But we need to get 8. So if you write 10 here as the y coordinates of this point here, so it is too much. So we need to subtract the value of b from it because b is the y-axis, okay, that will reduce this 2k, because 2k is 10, 2 times 5, 10, but it's too much. Okay, so we need to remove this distance from here to here. We need to remove it from here. So 2k will give you from here, okay, from here to here, okay, is 2k, okay. But what we need is from here, for instance, okay, from here, okay, to here is what we need, okay. So we have to do 2k then minus this one now. So we remove this one. So and this one is 2. So that is why you have this one will now be 2k. Okay, this will be 2k minus b. So that is what we are going to have here. Okay, so instead of writing 8 here, so we just write 2k, that is 2 times 5, 10, write 10 minus 2. So that's what we write here. So instead of writing 8, we just write 10 minus 2. So this is the same as this. Okay, so if you do 2k, so that will be 2 times k, that will be 2 times 5, 10. 10 minus b, so 10 minus 2 is still 8. Okay, so that is what I intended to explain to you. Okay, so this is very, I think it should be clearer now with this explanation. Okay, so let's write a here and we write 2k minus b. That will be the coordinate of the reflection. So let's go to the next question. That will be question 3. Question 3a, the table shows the waiting times for 120 patients at a medical center. Calculate an estimate of the mean waiting time. So we need to tabulate this. Okay, better still, we can just, I think we can work directly here. Okay, yeah, so let me call this the midpoint here. So I'll take it as x. Okay, I think it's better to write here. Let me just do something. Okay, so I'll just do a kind of, let's have 1, 2, 3, 4, 5, 6, probably 6 lines. So let's start from here. 1, 2, 3, 4, 5. I think I can put 1 here. Okay, so Then probably we should have these two. Okay, just to draw a table. Okay, so we can put this should be for the class interval. So we should already have here. So 0 less than t less than or equals to 10, 10 less than t, and t is less than or equals to 20, 20 less than t, and t is less than or equals to 40. So next one, 40 less than t, and t is less than or equals to 50. Then 50 less than t, and t is less than or equals to 80. Okay, so then the frequency is given here. So I have the frequency that is 2, 46, 33, 26, and 13. So we need to find the midpoint, okay, the mid value of this class interval. So I will call that x. So that is 0 add 10, that's 10 divided by 2. So I have 5. Then the next one will give me 15. This will give me 30. This will give me 45, and this will give me 65. So I need to get the product of f and x here. So this will give me 10, this and this, 690, this and this. That will be 990. So this and this will be 1170, and this will be 845. So we need to get summation f. Already we were told that there are 120 patients. So this we add up to 120 as the total of the frequencies. And this, if you input this into a calculator, you should get 3,705. Okay, so an estimate of the mean will be 3705 divided by 120, and that will be equals to 30.875. So you have 30.875. Okay, the next one, the histogram shows some information about the waiting times at a different medical center. Okay, so frequency density is given as the vertical axis, and the horizontal axis is the waiting times in minutes. Okay, so the total number of patients is 90, and no patient waits for more than 80 minutes. So this is the maximum number here. Okay, so and we know that the summation of the frequencies is 90. Okay, so I think can write something like this. So the summation of the frequencies, okay, that's the total frequency, will be equals to 90 as shown here. Okay, so complete the histogram for the patient that have a waiting time between 10 and 30. So we need to draw this between this and this. For us to draw this, we need to know the frequency density. Okay, and this will require this will require us to do some stuff here. Okay, so we know that the formula for the frequency density, so FD for frequency density, so it will be equals to frequency over the class size. Okay, so from here now we can now get the frequencies. Okay, so the frequency will be equals to frequency density multiplied by the class size. Okay, so from the table we need to do some things here. So when the class size is from 0 to 10, so the class size is 10, 10 minus 0, that is 10. So the frequency density is here. Okay, so I can get the frequency from here. So the value of a line here is so if you do 0.5 divided by 10, so that will be 0.05. So the value of a line here is 0.05. So I do this a lot. It makes my work easier. And the value of a line here, of course, is 1. 10 divided by 10 is 1. So I'm pretty good here. So the value of a line here is 1. Okay, so that means to have 0.1, you have to take 2 lines. So this one now, this is 0. And the essence of doing this, you can count the number of lines and multiply by 0.05 to give you the exact value. Take for instance now, if I multiply 10 by 0.05 to give me this. Let's say I want to get this particular point now, this particular one. So this will be 10, 11, 12, 13, 14, 15. So I'll just do 15 multiplied by 0.05. It will tell me the exact number that should be here. Okay, so I don't have to do it manually. Okay, but if you are good at counting manually, you can also do so. That is, this will be 0. So 1, 2, that will be 0.1, 1, 2, 0.2, 1, 2, 0.3, 1, 2, 0.4, 1, 2, 0.5. So each two line, for every 2 lines, you have 0.1. So you can also count like that too. So it doesn't matter. Okay. So you can use anyone that is convenient for you. Now, this particular spot now, what is the frequency density here for this particular one? So this will be 1, 1, 2, 1.1, 1, 2, 1.2, 1, 2, 1.3. Okay, so I can get the, okay, let me confirm that again. This is 1, 2, that is 1.1, 1, 2, 1.2, 1, 2, that is 1.3. So I will tag the frequency of this one by F1. Okay, so I think I can just do something here. So I can say F1, that's the frequency of the first class interval. So because to frequency density, which is 1.3, multiplied by the class size, which is 10. So this will give me 13. Okay. So because I need to get the frequency of this one, okay, so as to get the frequency density. Okay, so the second one is unknown. So this is the third one, is from 30 to 50. Okay, so from 30 to 50, so the class size will be 50 minus 30, that will be 20. Then the frequency density is given as 1.5. So this is super easy. So I'll call it F3 because we skipped one here. So it will be equals to 1.5 times 20. So that will be equals to 30. Okay, so we'll get the frequency of the next one, that is from 50 to 80. Okay, and it is this particular line here. Let's trace this one. Okay, so that is 0.4. Okay, because this is 1, 2, 0.1. Okay, so that will be 0.4. So I can say F4 is equals to the 0.4 multiplied by 80 minus 50, that's the class size, that will be 30. Okay, and this will be equals to I think 12. 4 times 3, 12. So this will be equals to 12. Okay, so we know that the summation of all this frequency, okay, is 90. So that means I can get F2 from here. So F2 will now be equals to 90 minus 13 minus 30 minus 12. So F2 will be equals to, if you input this into your calculator, so it should give us 35. So that means the frequency is 35. So since we know the frequency now, so we can now get the frequency density for this class, that is from 10, between 10 and 30. Okay, so we can do something now. So the frequency density is equals to frequency over, so let's write it here. Frequency density now is equals to frequency over the class size. So the frequency is 35, and the class size is 30 minus 10, that is 20. So if you do 35 divided by 20, so you should get 1.75. So this is 1.75. Okay, so we need to draw the bar now. So for this now, it has to go to 1.75. So this is 1.5. So for instance now, if you want to get this 1.75 now, so how many lines will give you some 1.75? So it's easy. So it will just divide 1.75 by value of a line, which is 0.05. So if you divide 1.75 by the value of a line here, which is 0.05, you get 35 lines. So that means if you go straight to 35 lines, that is where you have 1.75. So this is 10, 20, 30, so 31, 32, 33, 34, 35. Okay, so it's here. So it will be there. And if you want to count manually, this is 1.5. Okay, so 1, 1, 2, 1.6, 1, 2, 1.7, then 1. So that will be 1.75 because it will not get to 1.8. Okay, so that is one way of doing it. So it's good. You can only use the one that is the best for you. So now I'll just draw from here to this place here. Okay, then this one here. Okay, sorry, let's take that again. I think I can use okay, I think I'm okay with this color too. So let's draw the other one here, then we can join them together like this. Okay, so that is how you can complete this, and you may want to maybe shade the something in troubles. Okay, I think I can use a bigger one, something like this if you want. So you have to take your time, need to be very careful. Okay, like this, something like this. Sorry, shouldn't be too much. You should wash the height as well. Okay, so we can just finish it up by doing this gently. You have to shade everything so that everything will look alike. Okay, so that's just the point there. Okay, so that's how to complete this. Let's go to the next question. So let's go down if you have any question down. No. Okay, so the next question is question 4. Enzo, Rashid, and Blessy each swim as many lengths of a swimming pool as they can in 15 minutes. The results are shown in the table. So this is the number of lengths for Enzo, Rashid, and Blessy, respectively. So find the number of lengths Enzo swim as a percentage of the total of the length all three people swim. Okay, so Enzo is 11.25. So if you add these together, these numbers, you should get 50. So write 50, then multiply by 100%. So straight away, this will give you 22.5%. So round figure 2, write the ratio of the number of lengths each person swim in the form this ratio, this ratio, this. Okay, so to be E for Enzo, ratio R for Rashid, ratio B for Blessing. Okay, so their swimming length is up there, so I can just write 11.25, then 18.75, and this one is 20. So let's divide by the smallest number here. So by 11.25, 11.25, 11.25. So this will give us 1. This will give us as a fraction 5 out of 3. So as a fraction, this will give 16 out of 9. But we want to have whole numbers, okay? So the LCM, so we need to linearize. So this one is just like 1 over 1. So the LCM of 1, 3, and 9 is 9. So we can just multiply this by 9. so by 9, so to give us 9, multiply these two by 9, so 3 here 1, 3 and 9, 3, 3 times 5, this will give us 15, multiply these two, okay, by 9, so let me put this one down so that it will not be confusing. So by 9, so it will give us 16, so we have 9 ratio 15 ratio 16 respectively. Okay, so let's go to the next question. Roman figure 3. Each length of the pole is 25 meters. Work out Blaze's average swimming speed for the 15 minutes. Give your answer in meters per second. Okay, so for this, we need to get the distance covered. Okay, so the distance covered will be, the total distance covered will be, okay, let's say the total distance covered will be equals to 25 meters multiplied by the length of Bazi. I think it is 20. Yes, good, 20. So multiply by 20. So this will give us 500 meters, and the time will be equals to 15 minutes. So we want to have it in seconds. Okay, it will be 15 times 60. So that will be the minute in, okay, I can put this one in bracket at these seconds. Okay, so the average swimming speed now will be equals to, that is the speed equals to distance over time. So that will be equals to 500, okay, divided by 15 times 60. So from here, the last 0 will cancel the last 0. So 5 in 50, that will be 10. 5 here, that will be 3. 2 in 6, that will be 3. 2 in 10, 5. So we have 5 over 3 times 3, 9. So this will be 5 out of 9. That will be speed. Then part B, Rashid continues to swim at the same rate. So if he continues to swim at the same rate, that means it covers equal distance in equal interval of time. So that is for every 15 minutes, okay, for every 15 minutes, so it covers equal distance, and its distance is 18.75. okay, this is its distance. For every 15 minutes it covers this distance. So let's scroll down. So it covers 18.75 length, okay, of the distance. And don't forget that each length is 25 meters, as we were told up here. Can you see? So each length of the pole is 25 meters. So that means for every 15 minutes, okay, for every 15 minutes, so it covers, it implies 18.75 times 25 meters, and eventually this will be equals to, take your calculator and do this, you should get 468.75 meters. So for every 45 minutes it covers 468.75 meters. Now, so how many lots of 15 minutes are there in 5 kilometers? So to do that, so 5 kilometers is the same as 5,000 meters, okay? So if you divide the 5,000 meters by this, it will give you the lot of 15 minutes in 5,000 meters or 5 kilometers. So divide by 468.75, okay, meters. So this will give you 10.6667. So it means there are 10.6667 lots of 15 minutes in 5 kilometers. Okay, so then to get the time taken to cover the 5 kilometer, okay, so the time now will be equals to 15 for every minute, for every 15 minutes, okay, times, so it will cover this lot of 15 minutes in 5 kilometers. So we have to multiply by 10.6667. so which is equals to 160 minutes. Okay, so this 160 minutes is the same as 2 hours 40 minutes. So 2 hours 40 minutes. That is interesting. Okay, so Blessy swims for 1 hour. The number of lengths she swims decreases by 5% every 15 minutes. Okay, calculate the number of lengths she swims in the final 15 minutes. Okay, so don't forget that the length she swims decreases by 5% every 15 minutes, and that will be exponential decay. So we can use this: y is equals to ab to the power of x. That's where a is the actual one. So if you go to Blessy, the swimming length of Blessy is 20. Okay, that's the number of length is 20. So if you go to the table, okay, so I've visited this several times, so I know it's 20, so I don't need to go back. Then b will be equals to 1 minus r, since it is exponential decay. Okay, so if it was exponential growth, it will be 1 plus r. So, and our r equals to 5%, which is equals to 0.05. So b will be equals to 1 minus r. So b will be 1 minus 0.05, and that will be 0.95. So this is the value of b. Okay, and this is the value of a. So, and x now, so x will be equals to 3. Okay, because it is within the final one, so it should be 3 out of the 4 quarters. Okay, because 1 hour, you can see 15 minutes, 4 lots of 15 minutes in an hour. Okay, so, and in the final one, okay, it's still on, so we have the first 3. Okay, so here we're going to say y is equals to a, which is 20, okay, into 0.95 to the power of 3. Okay, so you can just demarcate this ones like this. Okay, so that y will be equals to 17.1. So we have 17.1 here. Then part B, another swimmer, Adam, swims 400 meters correct to the nearest 25 meters. Okay, so this takes 10 minutes correct to the nearest minute. Calculate the number of distance Adam swims in 1 hour at this rate. Okay, seeing questions like this, you should know that we are dealing with lower and upper bounds. Okay, so let's start with the distance. Okay, that is for 450 meters. Okay, so it is correct to the nearest 25 meters. That means we count in 25. Okay, so the next one will be 475. We keep on adding 25, okay, meters, and the one before it, okay, so will be 425 meters. Okay, so the lower bound will be the mid number here. So if you add these two and divide by 2, you should get 437.5. So this is the lower bound. Okay, and the upper bound will be the mid number here. So if you add this and this together, okay, so you should get 462.5. so I can denote this by lower bound LB, and this will be upper bound. This will be upper bound, so UB. Okay, so for the time 10 minutes correct to the nearest minute. So if you have 10 minutes here, so to the nearest minute, it means we count in ones. So the next one will be 11 minutes, and the one before it will be 9 minutes. So also we can get the lower and the upper bounds. So the lower bound will be the mid number here. So that will be 9 plus 10, that is 19. 19 divided by 2, that's 9.5 minutes. Okay, so this is also the lower bound. Okay, and the mid number here, so it will be 10 add 11, 21 divided by 2, that is 10.5. So this is the upper bound, we have the upper bound here. Okay, so calculate the minimum distance Adam swims in 1 hour at this rate. Okay, so what we're going to do, the minimum, okay, the minimum distance. Okay, so minimum distance will be, can I write here? Okay, I think I can scroll up a little bit. Okay, good. So minimum distance so will be equals to that will be the lower bound of this distance, okay, over the upper bound of the time. Okay, so that is what we're going to have there. So it will be the lower bound to be equals to let's denote it, lower bound of distance over the upper bound of the time, then multiply by 1 hour. Since our time is in minutes, so it will be 60 minutes. Okay, so if we do this, it will be the upper bound, the lower bound of the distance is this, and the upper bound of the time is this. So that means you're going to have 437.5 over 10.5, then multiply by 60 minutes. So this will be equals to 2,500 minutes. Okay, so you have 2,500 meters rather. Okay, so that's what you get. So let's go to the next question. That will be question 5. A box contains 3 blue pens and 5 red pens. Okay, Mia picks a pen from the box at random. Find the probability that she picks a red pen. So red pen is 5 and the total is 8. So we just have 5 out of 8. Part B, Mia puts the pen back into the box. She then picks a pen at random, okay, and replaces it. Okay, so that is with replacement. She then picks a second pen at random. Complete the diagram. So for the first pen, so blue will be 3 out of 8. This will be 5 out of 8. For the second one, so since it is with replacement, so you have blue to be 3 over 8 and red will be 5 out of 8. Okay, so for this one, blue will be 3 out of 8 and red remains 5 out of 8. Okay, good, we have done that. Find the probability that Mia picks 2 pens that have the same color. So it will be probability of, since we have 2 colors, BB, okay, or probability of red. Okay, so for this one now, it will be just 3 over 8 times 3 over 8 for the first and the second, plus 5 over 8 plus 5 over 8. Okay, so this is pretty times rather, not plus. So this is multiplication. Okay, so you can work out this straight away and you just get your answer. This will be 9 over 64 plus 25 over 64. Okay, this will be equals to 34 over 64, and that will be equals to 17 over 32. So you have 17 out of 32. Okay, so let's go to the next one. That will be this. Mia now picks 3 of the 8 pens in the box at random without replacement. So find the probability that she picks 2 blue pen and 1 red. We have 3 arrangements here. So we are considering B, B, and R. Okay, but we don't know the order. So for that reason, so it could be probability of B, B, R. okay, or probability that it is RBB, and the last possibility is probability of what B, R, and B. So without replacement. So if you follow this now, this, so it's like eventually these three are identical. So we can just do only for one, okay, and multiply by 3. So we just take probability of BBR, okay, multiplied by 3. So just to save time, okay, so this will be equals to BBR. So for B, first B, it will be 3 out of 8. So without replacement, so it will be, the total will be 7, and this will reduce to 2 out of 7. And now the total is 6, and we are taking from red. Red is 5, so that will be 5 out of 7. Okay, everything multiplied by 3. So if you input this into your calculator, so you just get 15 out of 56. Okay, because you can actually simplify. Sorry, this is 6, not 7. It is 6. Okay, so you can actually simplify this. 3 times 2 is 6, so it will cancel 6 there. Okay, so you are left with 5 times 3. So 5 times 3 over 8 times 7. So this is 15 out of 8 times 7, that is 56. So you have 15 out of 56 as the answer. Okay, so let's go to the next question. That will be question 6. Question 6. The diagram shows a field A, B, C, D. A straight line AC goes across the field, as you can see. Show that AC is equals to 1028 meters, correct to the nearest meters. So we want to find the length of AC. So here we can use cosine rule. Okay, so that will be okay, so AC squared will be equals to, if you understand cosine rule, so just be square of this equals to square of this plus square of this minus 2 times the product of these two, then cos 106. Okay, so I'll not write any formula, so I'll just do that. So it will be AC squared is equals to 420 squared plus 830 squared minus 2 into their product, that is 420 into 830, okay, then cos 106 degrees. Okay, so if you input this into your calculator straight away, so AC squared should be equals to 105 7474.36. So from here you can take square root of both sides. Okay, so this will cancel this. Okay, let's scroll down a little bit so that AC will be equals to, you can extend this, it will be equals to 1028.34 and approximately 1028 to the nearest meters. Okay, so that's that. So for part B, angle ACB is obtuse. Calculate angle ACB. Angle ACB. So we want to find this angle and it is obtuse. Okay, so what we can do here, we can use sine rule here. Okay, so we can use sine rule. Since we know this side, we know this angle, so we know this side, we are finding this angle, so we know this angle, and we already found angle C, so that is, I think we found that to be, let's check again, 1028.34. Okay, so I just put this one 1028.34, so that is AC, so I can use this. So I'll just take this. This is angle C, so I'll take this to be side C. Okay, and this is angle B, so I'll take this to be side B. Okay, So using sine rule, so I'll just have c over sine c to be equals to b over sine b. So I want to find angle c. So let's make sine c the subject of the formula. So sine c will be equals to c times sine b over b. So I can take sine inverse of both sides. Okay, so this will be c is equals to sine inverse of this c times sine b over b. So I can plug in the value. I can plug in the values now. So c is equals to 1150 and b is that, and angle b is 62. So I have them now. So this will be equals to sine inverse of c is equals to 1150 times sine b is sine 62, okay, over b is 1028.34. So if you input this into your calculator, so you should get 80.9. But we are told that it is a reflex angle. So a reflex angle, okay, so this is angle ACB now, but angle ACB should be a reflex angle. So for that reason, so we say that ACB, okay, will be equals to, okay, let me just leave this one as C, okay. So ACB will be equals to 180 minus 80.9, so that will be equals to 99.1. So it should be 99.1. So an obtuse angle is greater than 90 but less than 180 degrees. Okay, so that will be the solution. So part C, part of the field which is triangle ACD is sold for $41,500. So calculate the cost of 1 hectare of this part of the field. Give your answer correct to the nearest dollar. So 1 hectare is equals to 10,000 square meter. Okay, so here we need to find the area of ACD. So let's go back. So the area of ACD, so it will be equals to the product of this side AD and DC, the product of these two sides, okay, multiplied by the sine of angle between them divided by 2. So that is the formula. So I'm going to do 420 times 830, okay, times sine 106, then divided by 2. So that is the formula. So let's go. So we see that area, you can just write here, area of triangle ACD, so it will be equals to 420 multiplied by 830 multiplied by the sine of angle between those two sides, which is 106 degrees. 106 degrees divided by 2. So if you input this into your calculator, so the area should be equals to 1675 17.91 meters squared. So this will be the area. Okay, so we have the hectare, okay, ratio, the square meter, so which is 1 to 10,000, okay. So now we have the area to be 167,547.91 now. So what was done to this to get this? You see that it is multiplied, you multiply by 167,547.91 divided by 10,000. So you do the same thing here. So it should be times 167,547.91 over 10,000. Okay, so if you do that, this will give you 16.7547 Okay, so that's what you get here. So this is the area of the triangle ACD in hectare. So I can say that, okay, so I can say that the area of triangle ACD, so it's equals to 16.7548 hectares. Okay, so that is what we have there. So I haven't got this, so we can now find the cost of what, of, we want to calculate the cost of 1 hectare of this part of the field. Okay, so but we know that this, okay, we can write something like this. So this 16.7548, okay, hectares of the land, that is ACD, was sold for $41,500. Okay, so 1 hectare so will be equals to, that is 41500, so divided by 16.7548, so which should be equals to 2476.90, so approximately 2477. So you have 2477. So that's what you have there. Okay, so to the nearest dollar. So that is the solution. So let's go to the next question. That will be question 7. A company makes scientific calculators and graphic calculators. So each day they make X scientific calculators and Y graphic calculators. Okay, so these inequalities describe the number of scientific and graphic calculators they make each day. So X is less than 180 degrees, Y is less than or equal to 90 degrees, and X plus Y, that is the sum of the calculators, is less than or equal to 240. Complete these two statements. So the company makes fewer than 180 scientific calculators each day. So the company can make a maximum of 240. Okay, as you can see here, 240 calculators each day. So part B, scientific calculators cost $12 to make. Graphic calculators cost $18 to make. So each day the company spends at least $2,700 making calculators. Show that this 2x plus 3y is greater than or equals to 450. Okay, so you have 12x plus 18y, okay, to be equals to 2700. So from here, okay, so this is 12x and this is 18y. So if you add the two together, it should give you this. So about 6 can go, divide this by 6, divide this by 6, divide this by 6. So you should have 2x plus 3y to be equals to 4, to be greater than or equals to 450. So that has been shown. Okay, so the next one, the region R satisfy these 4 inequalities. Okay, so we need to do this. X is less than 180, so 180 will be here. So each line is 5. Okay, so this is 180. So this is, let's remove 20. 1, 2, 3, 4. So it will be here. So we're going to remove 4 because 2 line is 10. Let's see 150, 160, 170, 180. So it is here. So I need to draw a line. So from here like this, I have to go up. Am I on the track? Yes. I'll need to complete this one later because I cannot draw it at a stretch. So let's go up. Then we'll pick this now. Then we'll complete. Sorry. So let's pick this. Then we'll extend this here. Good. Okay. So from here now, we asked to draw the 4 suitable lines and shade unwanted regions. So we need to get our unwanted regions. So the wanted regions are the regions that are less than 180 for this one now. So let's say for instance now, so what's the value of x here? If I pick a point here now, so x is 150. If I pick a point here, x is, so I need this area. So this region is wanted. So this is the unwanted region for this one. So I can just shade this one down carefully from here. So I don't want this side. So let's take it gently. Just taking my time. I think I can go like this. Just taking my time. Okay. So I can just do something like this. So this is unwanted here. Okay, so I can scroll up a little bit. Okay, so don't need this area. Oh, sorry. So don't need this side. Okay, so I just manage that like that. So sorry, I think I made a mistake here. So this is less than, it should be a broken line. Okay, so this should be a broken line. So I can just change that to a broken. Okay, so because it is less than, so this is a broken line, as you can see here. Then let's go to the second inequality. Y is less than or equals to 90 degrees. Okay, so y is less than or equals to 90 degrees. So 90 degrees will be here. Okay, so each value here we have 5. So this is 10, we take 90 away. So this is the needed line. So here. Okay, that is y equals to 90 degrees, but we need the values of y that are less than or equals to 90. So the needed region here will be here, so we don't need above, so we need to remove all these ones. So I can just take these ones like this. Okay, so don't need this area. Okay, so I can just scroll up. So I need to do this as well. Okay, good. So let's go to the third one. So is this. Okay, so we need to write that as in form of y equals to mx plus c. So this will be y equals to minus x plus 240 if you arrange. Okay, so from here now the gradient is equals to minus 1 out of 1. Then the intercept on y-axis is c equals to 240. So we are going to use this to plot the line. Okay, so let's find 240. So 240 will be, so don't forget a value of a line here is 50. So 240 will be before this as 10, 10, 20, 30. So 240 will just be here. Okay, so if you count, this is 10, 20, 30, and 40. Okay, so it will be here. So the first point will be here. So let's put it here. So this will be the first point. Then you fall by, the gradient is minus 1 over 1. It means you fall and run forward, okay, by 1 or by the same number. So this can also be maybe by 5 by 5. So it will still give you 1 minus 5 by 5 and so on. So from here now, so let me just count, because if I should use 1, 1, it will be too close. So I'll use the same equal step. Okay, I'll use equal steps. Okay, so from here now, 1, 2, 3. Okay, so 1, 2, 3. So this is another point here. So this is good for me. So from here again, I'll use 1, 2, 3, 1, 2, 3. Okay, so these are the points. Okay, so let me cross-check that again. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, oh. 1, 2, 3, 1, 2, 3. So now I can now draw the line from here. So since it is it has equals to, so from here just draw the line like this. You have to take note of these 3 points there. Okay, it must be exactly like that. So one has to be very careful. Okay, so let me see. Can I see this at a glance? Think, okay, I can still use this to guide myself. So from here now, I'll draw, but I'll ensure that it is on those 3 dots there. Okay, so I'm still watching. Okay, it's on those 3 points. I'm still watching. Okay, so you can see it should be on this line here. Okay, so let me scroll down. Okay, good. I think I'm good to go here since this is unwanted region. Okay, so the last one will be this inequality here. So I'll also rearrange this, so I can do that here. So it will be 2x plus 3y equals to 450. So let's rearrange this. It will be 3y equals to minus 2x, then plus 450. So y will be equals to, let's divide through by 3, minus 2 over 3x, then plus 450 divided by 3, that will be 150. So if you compare this with the general equation of a straight line mx plus c, so you see that the gradient is equals to minus 2 over 3, okay, and then the intercept on y-axis is 150. So we fall from the gradient, we fall 2 times and we run 3 times, starting from 150. So 150 is here. So the first point is this one. Okay. So let's fall 2 times to be 1, 2. Then let's run 3 times. 1, 2, 3. So this is this point. So I'll try to do as many as possible. 1, 2, 1, 2, 3. So from here again, 1, 2, 1, 2, 3. Okay, 1, 2, 1, 2, 3. So let me show this again. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay, so I can keep track. Let me see if I can do it once. Good. Okay, so this should help now. So from here now, so the first one will be here. Then it will pass through those points there. Okay, good. So here, I need to take, so I need the sum that will be greater than or equals to 450. So that's what I need. Okay, so let me take a point here. So I'm using this line now. So if I take a point here, let's say this one. So I want to get my wanted region, whether it is here or here. So let's pick a point here. So at this point now, x equals to 100, okay, and y is equals to 50. So we are dealing with 2x. Let's see, 2x plus 3y is it greater than or equals to 450. So let's check. So x equals to 100 here. So that is 200 plus y is equals to 50. That is 3 times 50. That is 150. So this will be 350. So that means this is the unwanted region. Okay. So I have to go again. So let's go gently again. Okay, so let's go gently. So let's go gently. Let's go gently. Let's go gently. Okay, so I can finish this up on time now. Okay, yes, from here now, I think I can remove this one a little bit. Sorry. Come on. Okay, so I think I'm cool now. So this is the, oh, for this one I didn't remove this one here. So for this, I forgot to remove this. Okay, so for this one now, this is the needed region. So it will be, sorry, let's pick this. So this will be the required region. So that is region R. Okay, so as we are asked to do so, by drawing the suitable lines and shading, find and label the region R. So that is the region R. Okay, so scientific calculator are sold for a profit of $10. So that is calculators, right? So that would be 10 into x. Okay, then graphic calculators are sold for a profit of 30. So that would be plus, let's see, 30 into y. So calculate the maximum profit made by the company in one day. So we need to find the maximum. So from the graph now, so let's go the maximum. So what will be the maximum for x and y? So the maximum value of x and y, okay, it will be for maximum value of y is this. It is pretty straightforward. That is 90. So that is 90. So I just want to find where x is maximum. So this one is out of it. So it's here. here. I think it's this spot here. So I'm looking at this spot here. That's about 155. So here's the spot. And x can still come. So if I should put this one here, it's a little bit lower here. This spot is lower. Okay. So looking at this spot here, this particular one here, there's a point here, and there is on that same spot we have this one here too. So I think I'll go with this one, that is 155, that is x, and y is equals to 90. So I'll go with that. So I'll put 10 into 155 plus 30 into y, so that is 90. So that will be 1550 plus 3 times 9, 27, then 00. So these two add up to 4250. So I'll put 4250 here. Okay. So let's go to the next question. So question 8. Okay, f of x equals to this, g of x equals to this. Find the values of x when g of x equals to 20. So that is x squared minus 16 equals to 20. So add 16, add 16. So x squared equals to 36. So x equals to plus or minus 6, negative 6, positive 6. So find f inverse of x. So let's y to be equals to 7 minus 3x, then y minus, okay, no, let's take 3, negative 3x to the other side, 3x equals to 7 minus y, x equals to 7 minus y over 3. So f inverse of x will be equals to, so 7 minus, so let's change y to x, then over 3. Okay, so this will be 7 minus x over 3. Okay, let's scroll down. So find g f of x plus 1. Okay, so g f of x plus 1 will be equals to g into f of x, okay, then plus 1. So because so we pass f of x into g as an argument, okay, sorry, so we'll pass it as a variable rather, okay, so this is not a programming class, okay, so f of x is equals to 7 minus 3x, okay, then g of x equals to s squared minus 16, okay, so that means instead of s squared now, so I will have 7 minus 3x, so this is f of x passed into g of x, then squared, okay, then minus 16, okay, so plus 1. Then if you expand this, we should get 49 minus 42x, 7 times 3, 21, 7 times 6, 21, so 42x, then plus 9x squared, then minus 16, then plus 1, okay. So if you simplify this, you should get x squared minus 42x, then plus 34, okay. 49 minus 16 plus 1, okay. So that will be the final answer here. So we have x squared minus 16, okay. sorry, x squared minus 42x plus 34. So that is what we get as our final answer. So round figure 4, on the axis, sketch the graph of y equals to g of x. So that is, we want to sketch y equals to s squared minus 16. Okay, so put x to be equals to 0. Okay, if we do that, so that means y is equals to negative 16. So this is the intercept on y-axis, probably somewhere here. That would be negative 16. Okay, something around here. Then put y to be equals to 0. So put y to be equals to 0. So that will be s squared minus 16 equals to 0. S squared equals to 16. So x equals to plus or minus 4. So we're going to have a point here. We're going to have a point here. So you can just sketch this like this. You can use your French curve. Okay, like this. There you can have something like this. So this is what you have. Okay. So let's go to the next question. Find the equation of the tangent to the graph of y equals to g of x when x equals to minus 3. Give your answer in the form this. Okay. So we have y to be equals to x squared minus 16. So let's find the y dx. Okay, because we need to get the gradient. Okay. So the y dx equals to 2x. Okay, so the y dx at x equals to negative 3 will be equals to 2 into minus 3 to be equals to negative 6. Okay, so that is the gradient. The gradient is negative 6. Okay, so what is y when x is equals to negative 3? So that's the point. Okay, so y is equals to s squared minus 16. So y is equals to negative 3 squared minus 16. So y is equals to 9 minus 16. Then y is equals to negative 7. So y is equals to negative 7. Okay, so that means it passes through the point s equals to minus 3, y equals to negative 7. So m is equals to negative 6. Okay, and the point is negative 3 comma negative 7. That is x1 equals to negative 3. Then y1 is equals to negative 7. So using y minus y1 equals to m into x minus x1. Okay, so this will be y minus negative 7 equals to m negative 6 into x, then minus negative 3. So this will be y plus 7 equals to minus 6x. So this and this will become positive, times minus 6, that is plus 18. Okay, sorry, minus 18. So this and this will be positive, then minus 6 times positive 3 minus 18. Okay, so if we rearrange, so we get y to be equals to minus 6 x minus 18 minus 7. So y is equals to minus 6x then minus 25. So if you scroll down, so you can put minus 6x minus 25 here. Okay, so that will be this. Okay, so let's look into part B. H of x equals to 3 to the power of x. So this is an exponential equation. It's of the general form y is equals to a to the power of x, and then this one, it is exponential growth. So if you have y equals to a to the power of minus x, this is exponential decay. Okay, but ordinarily in the standard form we have y to be equals to a to to the power of x plus b. So this b here is the asymptote, okay? So it is the asymptote, okay? So, but for this one now, so we have 3 to the power of x plus 0. That means y equals to 0 is the asymptote for this one, since it is missing. So I can just say h of x, which is y now, y is equals to 3 to the power of x then plus 0. So this is the asymptote. Okay, so from here I can just get the value when x equals to 0. Okay, when x equals to 0, so y will be equals to, okay, let's just write. So when x equals to 0, so y is equals to 3 to the power of 0, so which is equals to 1. So that means we have a point here. Okay, and this graph, what it does, it increases as it moves from left to the right. If you have like this, okay, and if it is negative power, so it falls as it moves from left to the right. So this one we just move like this, something kind of this. We have something like this. So that's what we're going to have. So and the asymptote will be the x-axis, y equals to 0. So write down the equation of the asymptote of to the graph of y equals to, so it is y equals to 0. That has been taken care of already. So let's go to the next question. That's question 9. Question 9. A, B, C, D, E, F, G, H is a solid cuboid. AB equals to 10 centimeters, BC equals to 8 centimeters, and CG equals to 17 centimeters. Work out the volume. Okay, so the volume is pretty straightforward. It will be 10 times 8 times 7 times 17 rather. So if you input that into a calculator, you should get 1360 cube centimeters. Work out the total surface area. So the total surface area will be 2 into product of the two numbers. Okay, you combine them. So I'll just go with 10 by 8, 10 by 17. So 10 by 8, okay, plus 10 by 17. Oh, sorry, close the brackets, then plus 8 by 17. So if you do this, you should get 772. Okay, no time to take them down. So if you expand this, you should get 772 square centimeters. Okay, so calculate the angle between GA and the base ABCD. Okay, GA, where is GA? Okay, this is GA from here to this place, and ABCD. So let's draw a line for ABCD like this. Good. So this is the required angle here. So we'll call this theta. So we need to find AC. So that will be the hypotenuse side. It will be 10 squared plus a squared. So I can do that again. So AC will just be square root of, okay, 10 squared plus 8 squared. Also, this will give us 12.80 centimeters straight away. Okay, then I can now use this to find the angle here now. So let's write something here. Okay, so if I draw the triangle like this is what I have, something like this, then finally this. Okay, so I have this place to be 17, then I have this place to be 12.80, that's 12.8. So, and this is the theta, so I can say tan theta equals to 17, okay, over 12.8. Okay, and theta, if you take tan inverse of both sides, tan inverse of 17 out of 12.8. I can input this into my calculator, and the value of theta will be equals to 53.0 to one decimal place, 53.0. So let's go to the next question. That will be question 9D. Okay, so a straight rod PQ is placed inside the cuboid. Then one end of the rod P is placed at the midpoint of AP. So that means this will be 5, this will be 5, okay, because everything is 10. And the other end of the rod Q rests on GH, okay, and the ratio of HQ to QG is 4 to 1, okay. So from here, I can just say, okay, this is HQ to QG, and it's 4 to 1. Okay, so what is the total length? So the total length is 10, and the total ratio, okay, I can say total ratio equals to 4 add 1, that is 5, and I can say the total length equals to 10. Okay, so how many lots of 5 are there in 10? So we have 2. So we have lots, I can just write here, lots of 5 in 10 will be equals to 10 divided by 5, that will be equals to 2. Once I get this, so this will be times 2, this will be times 2, so I have 8, and I have 2. So QA should be equals to 2, and this will be equals to 8. Okay, so what do we need to do now? Calculate the length of the rod PQ. Okay, so obviously we have to use coordinate geometry of maybe of solid, okay, or in solid that will be 3-dimensional. So we need X, Y, and Z respectively. Okay, let's start with point A. Okay, if we take point A as our reference point here now, so the X value at point A is equals to 0, comma, Y is also 0, okay, then Z is equals to 0 at point A. Okay, so at point P, the X is equals to from here to here. So for point P now, I can just say we need x1, comma, y1. Okay, let me write this, comma, z1. Okay, so for this one now, P will be equals to x1 will be this horizontal distance, that is from 0 to 5. Okay, I'll put 5 here, comma, so it's not having any vertical distance, so it will be 0, and it's not having any width, okay, no width, no vertical distance, so this will be 0 as well. So that will be the coordinates. Okay, so for point Q, okay, it will be equals to x2, comma, y2, comma, z2. Okay, point Q now will be equals to, let's see, so for it to come here, it has the horizontal distance, okay, of 8, so from 0 to 8, so that means s2 is equals to 8, comma, then it has the height of the width first, because this one is for the horizontal, the length, this is for the length, this is for the width, and this is for the height. Okay, so for the y value, that is the width. Okay, so from here, if you trace this one down like this, instance, if you trace it down, so it has the width, this one. So this is the length, okay, and this will be the width, okay, like this, something like this. Okay, so from A, for instance, now you move like this, that is the length, but for point Q, the length is 8 and the width is also 8, okay, and the height is from here to here, that is 17. Okay, so I'll put 8 here and this will be 17. Okay, so I have my value. So for point P, so I can now put it here, point P, I have 5, 0, 0. So for point Q, so I have 8, 8, 17. So x1 is equals to 5, y1 equals to 0, y2 equals to 0, z1 rather, z1 equals to 0, then x2 is equals to 8, y2 is equals to 8, then z2 equals to 17. So the length PQ is equals to, it will be square root of, that is x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay, so if I do that, so this will be equals to 8 minus 5 squared plus, this will be equals to 8 minus 0 squared plus 17 minus 0 squared. So everything under the square root. Okay, so this will be equals to 8 minus 5, 3 squared, 9 plus 64 plus 289 to square root. This will be equals to square root of 362. So this will be approximately 19.0 centimeters. So this is 19.0 centimeters. Okay, so that is the final answer there. So let's go to the last question, question 10. This rectangle has the area of 190 squared centimeters. By forming and solving an equation, show that s equals to 8.5. So the product of the two sides equals to 190 square centimeter. So x plus 1, okay, into 2x plus 3 equals to 190. So if you expand these two, so you get 2s squared plus 5x plus 3 equals to 190 degrees. Then you have 2s squared plus 5x plus 3 minus 190 equals to 0. So you have 2s squared plus 5x then minus 187 equals to 0. So from here, a equals to 2, b equals to 5, and c is equals to minus 187. So using x equals to minus b plus or minus square root of b squared minus 4ac over 2a. Okay, so we can use the other side here. So let's partition this. So this will be x equals to minus 5 plus or minus square root of b squared, that is 25, minus 4 into 2 into minus 187. Okay, everything over 2a, that is 4. So this will be equals to minus 5 plus or minus, everything should give you 1, 5, 2, 1 inside the radical, then over 4. Okay, so if you take square root of 1521, you should get 39 over 4. Okay, and since x cannot be negative, okay, so we'll just take x to be equals to minus 5 plus 39 over 4, which is equals to 34 over 4, which is equals to 8.5 centimeters. This has been shown. So we're going to work out the perimeter of the rectangle. So the perimeter will be equals to 2 into brackets sum of the two sides. It will be 2x plus 3, that is one side, plus x plus 1, that's the other side. So let's substitute the values. It will be equals to 2 into 8.5 plus 3 plus 8.5 plus 1. So if you expand this bracket, okay, I think it can be 2 into 17 plus 3 add 1, 4, 4 add 8.5, that is 12.5. So if you expand the bracket, you should get 5 and 9. So this will be 59 centimeters. Wow, we're almost done. Part B. So the diagram shows a sector OAB of a circle with center O and a chord AB. The shaded segment has area of 30 square centimeters. Show that R equals to 23.7 centimeters correct to one decimal place. Okay, so what we need to do from here, we're going to start from the segment, area of the shaded portion, which is area of a segment. Okay, so this is what we'll do. We'll say that area of the segment, so area of the segment, so it's equals to area of the sector, then minus area of the triangle. So area of the segment is given as 30, then it's equals to area of the sector. Let's see. So area of the sector equals to theta over 360 times pi r squared. Okay. So area of the sector equals to theta, which is 50 over 360, then times pi 3.142 times r, so which is r squared, we don't know, then minus area of the triangle. Area of the triangle will be product of the two sides, r times r, multiplied by the sine of angle between them, then divided by 2, that will be the area of the triangle. So it will be side r times side r, that will be r squared, times sine of the angle between them, that is sine 50, then divided by 2. Okay, so this will be equals to 30 equals to, if you do 50 times 3.142 divided by 360, so that will give you 0.4364 r squared, minus, if you do sine 50 divided by 2, so that will give you 0.3830 r squared. So we can factor out r squared, that will be 30 equals to 0.4364 minus 0.3830. So we factor out r squared. So this will be equals to 30 equals to 0.0534 r squared. So r squared will be equals to 30 divided by, okay, I can just write here. So let me remove this, sorry. Okay, so from here, so r squared will be equals to 30 over 0.0534, okay, and if you take square root of both sides, square root, so r will be equals to square root of 30 over 0.0534. Okay, so r will be equals to 23.7 centimeters. So that has been proven or shown. So calculate the perimeter of the shaded segment. So the perimeter of the shaded segment will be perimeter of the chord. Okay, that's so let's write perimeter of the shaded segment. That will be perimeter of the shaded segment. So will be equals to length of the chord AB. Okay, length of the chord AB, okay, plus length of the arc AB. Okay, so that is what we're going to do. That is from here. So this is the length of the arc AB, a length of the chord AB, and this is the length of the arc AB. So we have to add these two together. That is the distance around the shaded portion. So to get the length of the chord, okay, so you can just divide this one into 2. So this angle will be 25 degrees. This will be 25 degrees. Okay, and this one is r centimeters. So these two are identical. So you can just find, can partition this one to be m. Okay, so once you find am, so you multiply your answer by 2. That will be the length of the chord AB. Okay, so to get this, you can use opposite over hypotenuse. That is sine 25 degree. That is sine 25 degrees equals to opposite. So that is the am over the radius. So the radius now, so am is what you want to get. So am now be equals to r times sine 25 now. So we know the value of r. We just found that to be 23.7. Yes, approximately 23.7. So we can put that. So the length of the chord AB now will just be 2r sine theta over 2. That's the formula. Okay, so I just have to show you this. So let's go down. Yeah, so the length of the chord will just be 2r then sine theta over 2, okay, plus length of the arc. We know that should be theta over 360 times 2 by r. So let's key in the values. So it should be 2 into 23.7 then times sine theta is 50, so it will be sine 25 plus 50 over 360 times 2 times 3.142 times 23.7. Okay, so you can actually do this straight away. Okay, you can add everything together. So this will give you 20.03 centimeters plus this will give you 20.68 centimeters. So if you add the two together, you get 40.7 centimeters. That's two three significant figures. Okay, so you have 40.7. So this will be the end of the solution. So I already made a video. I've already solved the component 4.2 and this is 4.1. So watch out for component 4.3. Until then, have your fingers crossed.